Welcome to The Explainer. I'm going to be your mentor today as we boot up our developer sandbox. Today, we're walking through the definitive paradigm shift in enterprise software automation. If you've been feeling the macroeconomic pressure to optimize costs while somehow accelerating feature delivery, well, you're in the exact right place. Today, we're moving way past passive conversational AI and booting up a fully autonomous execution environment.
Here's our deployment roadmap for today. We've got 1. The agentic paradigm shift. 2. Lab 1. Cursor economic orchestration. 3. Lab 2. Google parallel execution. 4. Lab 3. Anthropic zero trust tunnels. And finally, 5. Compounding efficiency gains. Let's get right into it.
All right, Section 1. The agentic paradigm shift.
Let's take a look at this system boot sequence. Think back to right before this specific week in May 2026. Honestly, we were stuck. We had these brittle, passive AI assistants, right? Isolated code generation, context windows that just fell apart on long projects. But then, bam! May 18th hits with the Cursor Composer 2.5 launch. The very next day, Google Antigravity and Anthropic's MCP tunnels drop. Almost overnight, we saw a massive structural transition to fully autonomous execution. The whole prompts to action debate, yeah, that's completely over.
So, the industry has officially pivoted. It's no longer a raw model competition. It's all about operational dominance now. We're talking about agentic execution, deploying autonomous systems that can actually handle long-horizon reasoning, systems pulling off secure multi-file orchestration and parallelized sub-agent coordination, all safely tucked behind your corporate firewall. Because of this shift, your primary bottlenecks are no longer the AI's smarts, it's your infrastructure, enterprise integration, and cybersecurity.
Moving on to Section 2, Lab 1, Cursor Economic Orchestration.
Let's get hands-on and look at how Cursor Composer 2.5 tackles the massive cost issues with agentic coding. To integrate this, you need a few specific environment updates. First, in your IDE, make sure you're updated to version 2.5 or higher. Then, hit Command or Control-I to pull up the Composer panel, and select Composer 2.5 from the model array. Now, by default, it's going to route you to the fast variant. But here is an absolute pro tip. For big background tasks, like a massive code-base refactor, you've got to manually toggle this over to the standard tier in your settings. This is crucial for conserving your computational budget.
Now, if you're building headless automation and hitting the Cursor SDK programmatically, listen closely, because here's a massive trap you absolutely need to avoid. You must explicitly whitelist your tools, things like file editing or shell execution. But more importantly, you have to strictly bound your autonomous agent's loop. The operational payload has to include a max iterations parameter. If you forget to set that hard limit, your long-horizon agent could hit an unresolvable cyclical error state, get caught in a loop, and just keep spinning. You'll literally wake up to financially ruinous token consumption. Nobody wants that. But if you set it up right, what's the bottom line? Well, a standard 2 million token multi-file refactoring operation, and that's split between input and output tokens on the Composer 2.5 standard tier costs exactly $2.20. To put that into perspective, just look at this massive drop in operational overhead. Running that same multi-file refactor on a legacy flagship model like Claude Opus 4.7 used to cost an enterprise $66 per run. Now, down to $2.20. It's practically nothing. Your finance team is going to be absolutely thrilled. Cursor achieves this with a dual-tier pricing model that runs the exact same intelligent model weights, separated only by inference latency. It's a real game changer because it finally allows for massive, economically scalable background CI/CD operations that simply weren't viable before. Okay, let's jump into Section 3, Lab 2, Google Parallel Execution. Go ahead and open up your terminal because we are moving from code generation to full parallel orchestration. Google completely abandoned passive conversational AI for a natively integrated agent-first terminal environment. To deploy this, first establish a clean Python virtual environment. Then run a simple pip install Google Antigravity. Now, because this agent actually has shell execution capabilities, just relying on the defaults is a massive security risk. You have to strictly configure a declarative local agent config to act as a local firewall. You literally have to explicitly define your allow and deny policies before you even think about executing your asynchronous agent loop.
And Antigravity makes this secure by giving you 3 distinct lifecycle hooks: inspect, decide, and transform. Inspect is for read-only, non-blocking telemetry. Decide is a read-only hook that blocks for approval logic. And transform allows modifications and blocks for error recovery. So for example, you can easily use a Python decorator like @postToolCall. to bind an inspect hook. This will asynchronously log every successful terminal action your agent takes, straight to an external monitoring service. And the best part? It doesn't block the agent's momentum at all.
Now check out the raw infrastructural velocity driving this whole ecosystem. Google specifically optimized their Gemini 3.5 flash model for high-frequency tool calling. By running this on their TPU 8T and 8i silicon, this infrastructure pushes a truly staggering 289 tokens per second. It is flying. And because you're leveraging that extreme token speed natively inside your secure local harness, that paralyzing latency of multi-step agentic workflows, it's completely eliminated. We used to suffer through these agonizing 20 to 30-second wait states in sequential orchestration between iterative planning and execution. Now, with Antigravity's parallel sub-agent orchestration, that's slashed to under 3 seconds. It executes so incredibly fast that you can actually context switch to high-level architecture while the agents build the infrastructure in parallel behind the scenes.
All right, on to Section 4, Lab 3, Anthropic Zero Trust Tunnels. We absolutely have to address the elephant in the room: the catastrophic credential vulnerabilities of early agents. Historically, unleashing an agent meant taking highly privileged internal tokens and injecting them directly into the model's runtime context. Talk about a massive attack surface, but Anthropic solved this brilliantly by splitting the workload. The cognitive reasoning loop stays up in their cloud, but the tool execution and authentication are strictly confined behind your corporate firewall using an MCP tunnel. It's essentially a lightweight proxy utilizing a Cloudflare daemon to initiate an outbound-only persistent connection to their edge infrastructure.
Let's walk through the exact deployment script for this sandbox so you can see how it works. Step 1, generate your cryptographic domain and token right in the Cloud console. Step 2, drop into your localhost terminal, provision the local proxy directory, and export those secure credentials directly into your environment variables. Please, whatever you do, do not hardcode these secrets. Step 3, run that Cloudflare daemon on your host to establish the outbound connection to the Anthropic edge. And finally, Step 4, bind that active tunnel to your managed agent session in the console.
Now, because this is an outbound-only connection, your security team takes full responsibility for the local network configuration, and they don't have to open a single inbound firewall port. It relies on 3 overlapping cryptographic trust layers. You've got the outer MTLS, which simply validates the IP. Then the inner TLS acts as a secure wrapper, giving you end-to-end encryption to hide your payload. And finally, the OAuth edge ensures local role-based access control. Simply put, nobody is getting in without 3 separate handshakes.
The structural efficiency gain here is just absolute. You are completely removing that massive friction point with your InfoSec team. We are moving from brittle, vulnerable, inbound firewall exemptions and exposed service keys to decentralized, zero-trust, outbound-only local proxy execution. That means you never have to hand over privileged data warehouse keys or internal APIs to a third-party AI provider ever again. Think about it. A compromised cloud agent literally has 0 tokens to steal. That's a huge win.
Finally, Section 5, Compounding Real-World Efficiency Gains.
Let's tie all these deployment labs together and see how these architectures actually compound your team's velocity. The reality of this new paradigm is that maximum operational efficiency isn't about just picking one magic tool. It's about enterprise multi-model routing, dynamically sending the workload to the specific engine that dominates that exact bottleneck. For instance, set Cursor Composer Fast as your default for interactive IDE pairing. Route all those massive background refactors to Composer Standard to save some serious cash. Reserve your costly API calls to Claude Opus purely for deep architectural reviews, and dynamically invoke GPT 5.5 when you need really reliable, complex terminal fixes.
So as we wrap up, this explainer really proves that the era of conversational prompts, it's over. You now have the exact blueprints for economic scaling, zero latency parallel execution, and absolute zero trust security. The agentic web is in full production right now, and the tools are literally waiting in your terminal. With the friction of cost, latency, and enterprise security completely removed, I'll leave you with this question. What autonomous workflow is your engineering team going to build next?